For most of us, the surface of the sea is like a mirror to the sky. Out of sight, out of mind. We don't know what's happening beneath the waves. The deep ocean is the most important part of our planet, but it's the least known. We have better maps of Mars than we do of our own seabed. We need to go deep. We're aboard our mothership, the Baseline Explorer.
Everybody's ready! Hold them tight!
We're a few miles off the coast of Bermuda in the northwest Atlantic, preparing for launch. I'm Oliver Steeds, Mission Director of Necton and a submersible pilot.
Topside, Nomad.
Topside, go ahead.
Permission to open vents and dive.
Our journey down will be in this two-person Triton
Hatch
submersible.
secure. Life support systems are on and running. Safety briefing is complete. You're clear to dive. Both subs clear to dive. Dive, dive, dive.
We have a maximum operating depth of 1,000 feet. Our target is the top of an ancient undersea volcano.
Yeah, roger that. I'm gonna wait till we go flat underwater.
My co-pilot is Kelvin McGee, one of the most experienced sub-pilots in the world, and has clocked hundreds of dives, including on the Titanic.
Beauty, beauty.
Our sub is called Nomad. The sub in front is Nemo. We're diving together to maximize our scientific productivity, and we're looking out for each other in case something goes wrong.
Depth 60 feet on a heading of 90 degrees. Our life support systems are running and our vents are secure.
So this sort of changes here now. Getting more of this grass-like weed on the bottom.
Looks like we're driving into a meadow.
It does.
We're descending at 100 feet per minute and land in an algal forest. We're the first to research this unique ecosystem, one of the summits in a line of ancient undersea volcanoes, which rises out of the ocean depths to create the Bermuda platform. Suddenly, the abyss opens up beneath us, dropping away far out of sight.
Right on the edge of the wall. It's fantastic. Fantastic.
Yeah, right on the edge of the wall. That's quite a sheer drop down there as well.
Yeah, it's a sheer drop. So what we can do is we can actually turn around. We're back down the wall.
Spin around?
Yep.
To the right.
Mm-hmm.
Spinning around to the right so we can face the wall. Wow, that is absolutely spectacular.
Keep going all the way around because we're going to need to back up pretty quick. We're dropping pretty fast. So we're going to back away from the wall.
There we go, look at that. That is just stunning. Okay, we're now at 350.
Yep. Let's shoot for 400 feet.
We rejoin Nemo as the light begins to
We
fade.
are losing light fast here. We're losing light fast. Amazing, just as we hit 400 feet, the dark has really come in around us. You build up a lot of momentum in a craft like this. It weighs 3.5 tons, so if you start accelerating, you do need time to be able to slow down. The last thing you want to do is bump it into the wall. That wouldn't be a very good day at the office. We have reached our maximum operating depth on this dive at 500 feet on a heading of 123 degrees. Our life support systems are good.
Down here, the sun doesn't shine. These dark realms are home to 95% of our planet's biosphere, the reservoir of life.
And I can see the cable up on the bank up there.
Now we go to work. Our job is to document and sample what lives down here.
We're turning our lights on, our forward lights on now. We're going to turn our downward light on as well. So you can see the difference. That's all we can see. So Nemo that's in front of us is undertaking a visual transect. So it's got cameras pointed forward and then camera pointed down. The little lasers that you can see underneath Nemo are providing the distance which enables scientists to conduct the measurements which they need.
This is the harshest environment on Earth. Water pressure at this depth is 20 times that at the surface. It's like having a jumbo jet resting on your head. A tiny crack in our pressure hull and we would be crushed in a split second. And there are other hazards to avoid.
So just underneath Nemo you can see some wire. It's actually wire coral, and beneath them you can see a line. It looks like a fishing line or a cable of some sort. That particular line there is a major hazard for a submersible, because if we were to get snared on it, it would cause an entanglement issue, and we'd need to find a way to disentangle ourselves from that if we wanted to surface.
Our ocean is the beating heart of the planet, but it's changing faster than at any time in the last 300 million years. Our mission is to diagnose the health of our planet's heart.
We've got some fish passing to our right. Look at those. What are those? A couple of jacks.
Yep.
Quite small, those jacks.
Yeah.
Our average mission takes 4 hours. It's time to return to the surface.
Here we go. Very slow ascent.
As we inch upwards over the limestone slopes of the volcano, the light starts to return and reveals hidden wonders.
Come up, we're going to be able to peek in behind that cliff. We got some, what are those, wire corals up there and some black corals?
Yep.
Shades of blue is just magnificent. Wow, look how steep that cliff is. That is out of this world. That's like standing on the halfway up a mountain and just looking at it.
Yeah.
But imagine like if we were on land, we'd basically be a bird right now, looking ahead at that wall.
Yep.
Depth 388 feet, heading 001 degrees. Our life support systems are running. Topside, Nomad. Okay, we're coming up pretty quick.
At last we see the surface and return to the world of sunlight.
Passing through 60 feet.
Most life on Earth depends on the sun's life-giving rays. Yet the vast majority of the biosphere, the planet's habitable space, lies in the deep ocean and never sees the sun.
Copy that, we are clear to our surface.
Yeah, we're coming up slow. We're good.
Everybody ready? Hold them tight! Tight! Coming in!
Only a tiny fraction of the ocean has been explored. Each journey into the unknown pushes back the frontiers of our knowledge and reconnects us with our blue planet.